Hi, everyone. Good morning. Can everyone hear me? Yeah? Okay. Thank you very much. So we're from Brazil. We are here representing the Alpha Lumen School. Unfortunately, they were not able to join us today. So we are going to take some 3 minutes to go through their presentation and another 3 minutes to speak a little bit about what allowed us to be here and about this collaboration, okay? My name is Roberto Fanganiello. I'm a biologist, a stem cell biologist and geneticist. I coordinated the team together with Dr. Jeff Michaelis. I want to thank also Dr. Jeff Goldstein for allowing us to be here and for organizing everything, and also John Hamill. And so the title of this presentation is Adsorption of Bioactive Factors on Hydroxyapatite. Can I pass here? Yeah? Okay. Basically, the idea is to study bone health in space. We know that there is a possibility of a problem with bone health in astronauts after something like 2 weeks on space in microgravity. And the idea here is to try to associate secretome from mesenchymal stromal stem cells with hydroxyapatite under microgravity in order to study the possibility of regenerating bone or treating osteoporosis in these astronauts. So basically, like I said, we know that there is a bone problem in astronauts in space, and this can also be translated into Earth to the elderly, and we wanted to investigate this problem. So basically, here is the list of researchers from Alpha Lumen. Here is the problem to be tackled and the question to be solved, the significant bone loss that astronauts suffer. And we want to use microgravity and mirror the experiment here on Earth with normal gravity in order to understand, for example, if the secretome of these MSCs is able to improve bone health in these conditions. So basically, one of the issues is to understand the role of hydroxyapatite, which is a biomaterial already used here on Earth in several different applications like orthopedics, prosthodontics, dentistry. So it's well known, the role of hydroxyapatite in bone healing. Also, I mean, the interface and the dynamics of association of this secretome from cells with the biomaterial, that's another question. Key proteins involved, so we know, for example, that the secretome is a batch of different types of proteins that can have different functions, so this is another thing to understand. And of course, the role of microgravity. This is basically the overview of methodologies that is going to be used. So, I mean, basically different types of reagents that we are going to use to activate and deactivate the experiment. Here is the protocol for what the astronauts are going to do at the ISS. And this is the techniques that are going to be used after the experiment is back, both the one that is going to come back from space and the one that we are going to run here on Earth, okay? So here is the group of institutions that contributed for this project to happen. I'm going to give the floor to Dr. André Vargas, one of the supporters of this project, so that he can speak a little bit about our collaboration. We have 2 minutes, right? Okay, thank you.
Thank you so much. Good morning, everyone. We are here to inspire and encourage, as you can see here. And I was inspired and encouraged 3 years ago when I came to Kennedy Space Center. That's why I'm using the jacket also. Visiting the gateway, I thought about how can I do some research related to that. And I met these guys from Mark Ryle and Anderson, Dr. José Ricardo and Dr. Verou from Anderson. And these guys had this project right here. So I could join with my institute this opportunity. And actually go from research at the university to initiative like this and explore the microgravity, having the opportunity to test at the space station and then compare, looking for different kind of treatments for us in the near future. Our Cryo, it's a company based on isolation and cryopreservation of stem cells. Also a biopharmacy company, and we know now that regulations and bioethics are the main goal to go further. This is another whole. This entity looks for different kind of opportunities in the medical field, and now we know that we can build biological treatments and using artificial energy, even robotics, we can go further and inspire even new generations, new researchers. This is our main goal in Brazil, and this is a big opportunity for all of us. Thank you.
Thank you very much. Do we have any questions for this group? Oh, over here.
Hello,
Hi.
my name's Ari. I'm from the Community College of Allegheny County in Pittsburgh, Pennsylvania. Could you just elaborate a little more on what kind of mesenchymal stem cell you're looking at? Like,
Yeah, sure. Yeah, so there are, for those who do not know, there are many types of mesenchymal stem cells. For example, especially based on where we isolate them from. In this case, it is from the periosteum of the palate. So basically, we isolate them with a little punch and put them in culture to grow, characterize them. There is several experiments that we do, and then isolate the secretome, basically the batch of proteins that are secreted from the cells. Yeah, thank you for the question.
Got another question over here.
As we know, we have different sources. So the cord cells, and as plastic surgeon, we have the product of the liposuction, the lipoaspirate, so stem cells from fat.
I have a question. Do you count other factors that affect the bone health, like sunlight?
I'm sorry, if we count, can you repeat?
Other fact, sunlight affect bone health too.
If sunlight affects
Yeah.
bone health, right? Yeah. Well, that's a very good question, and my answer would, well, Andre is a plastic surgeon, so he can also answer, but I think it's indirectly, yes, because of course, I mean, sunlight affects our circadian cycle, so it's an indirect influence on bone health. It's not going to be a direct influence of sunlight, but the cycle of light and dark, yes, it affects it indirectly, because we need, I mean, it regulates everything, sleep and like eating and etc. So yeah, and also it has a psychological effect. So it's an indirect effect. Do you have something to add? Yeah.
All right, thank you very much.
Okay.
Can you just add from a clinical perspective, maybe?
Yeah, actually, understanding the cells, we can understand a little bit more about our body. So having the cell cultures with different kind of stress, we have different kind of responses. This is about our body as well. So for sure, it counts.
All right, thank you very much.
Thank you very much.